Hey guys, Steven here today. And today what I wanted to talk about is swag implementation, right? So it's essentially segueing from the last video on swag design, right? But the main thing that I essentially wanted to talk about in this video was the importance of focusing on the concrete classes, right? So what I call essentially the meats of your system or program, whatever it is you're building. So what do I mean by that? If you look at a program in terms of maybe the user interface, right, and then behind it there are algorithms, right? If you can take an even step further, you can actually start to realize that there are essentially key classes or key functionalities, key parts of the program that are essentially the heart of it, where without it, you don't really have anything, right? I always talk in terms of objects and classes because at the end of the day, that's all it is, right? No matter how, whatever context you want to talk about, whether it's machine learning, data mining, neural networks, or even fucking building apps, right? Like Snapchat, or building like a website like Facebook, or building a search engine, right? You can always, on some level, relate to it in terms of the classes and the instances, or the classes and the objects that build those systems, right? And to highlight the importance of concrete, or not concrete, but yeah, the real concrete classes that essentially form the basis of that program, you can simply think about just these last three mentioned systems, right? Like for example, in Snapchat, if I want to build a Snapchat, I have to make sure that first I create an object that saves the picture that I take from my camera app, right? And then on top of that, I also have to make sure that this object, I can pass in the values for the sender, right? You know, when you're in Snapchat and it tells you where do you want to send this to, right? So I have to make sure that it passes or inputs or receives those inputs perfectly, right? Like it receives where it's headed, right? The intended party, and then on top of that, it receives particular values that are attributed to that particular type of content. So if it's a picture, I got to make sure that like there's something that I can clearly set to where it's like 10 seconds long or it lasts for forever, right? Or if it's like a video, I have to make sure that it doesn't exceed what I think it was like 10 seconds or something like that, right? So these are all values that are passed in, maybe has like a parameter, right? Or has, these are values that are passed in from like a function, right? From a function, it sets the attributes of the class, right? It could be member variables, and then making sure that that works well. And so now when you're just talking about Snapchat, you realize, well, there's probably going to be some solid networking protocols that have to take in play, right? Depending on, I mean, I don't know how their infrastructure does it, but I'm sure they have a way of referencing every single username, a way of referencing the story, and a way of ensuring that you can always communicate with that, right? So they're on top of the meat of the class, the meat of the program itself, which is like the object that handles everything that is your data when you're creating a piece of content, like taking a picture, a story, a video. On top of that, then there's also like a pipeline classes, right, that like deal with the networking and ensuring that that piece of content goes where it needs to go, right? So that's what I meant by networking, right? Like, and you start dealing with like messing with servers and clients and ensure that the connections always sound, right? You start implementing like safeguards, ensure maybe you can't post two stories at the same time from like the same account, like small things like that, right? Nuances. And then you also realize that in them sitting down and being thoughtful about what they're actually trying to achieve at the design level, it actually hammers out or wrinkles out these small weird nuances, kind of just like I mentioned, for example, about the no to story from a different account, even though it's like, I mean, from yeah, no, you can't post like um, the same story from two different devices, even though it's the same account. Or you can't be logged in to one account from two different devices at the same time, right? And if you can even test for yourself, like every time you do that, it always logs you out of the previous one, right? Small checks and balances like that are actually really fucking crucial to like security and making sure things run as they should, right? That's a Snapchat. If you're Facebook, you want to make sure that like the object or the class, the meat of it is essentially something that like receives all the fucking possible values for a user, right? Like things like what is the current content on their news feed, right? Like if I post, if I want to set my news, my latest what's on your mind thing or string to like a message that I wrote, like when you um, when you set your when you answer, you know, that field, what's on your mind, Steven, and you type it in, right? You want to make sure that there is a way of getting that, like what was the last thing set, right? And then on top of that, you also want to make sure there's a way of getting maybe likes, right? Videos that you've uploaded, right? Pages that you're maybe managing or created or even just liked. All these sorts of things, right? So that would be the meats of it. And then on top of that, you want to get essentially, I'm guessing there's like a whole bunch of fucking functions that deal with just using that object. And that's probably why their infrastructure is so huge. Because on top of getting that, you want to make sure that you can also like use it instantaneously without like the system slowing down or anything of that matter, right? So that's like that would be the concrete object, the meat of that system, the meat of Facebook, right? This huge class that has all these member variables that are attributed to all the particular things that a user can have, like, or do, right? The user data, right? So for Google, maybe you want to make sure that the concrete class obviously has it receives as an input like keywords that someone puts in the search bar, right? And then the output, or the, I guess you can say, the most important part for that class would be to ensure that it has a solid searching function, right? Like something that like sifts through, not only sifts through data, but also returns it in a way that is most relevant, right? Maybe it has a particular way of thinking about, okay, this is a keyword. Maybe there's like a trillion databases that it has at its disposal, right? Those are things that people never consider. So it has like, and then it's like, okay, maybe based on this keyword, I should probably search in that database or this one, etc. Right? I don't know how that works, but my guess, my point is that its searching functionality has to be fucking on point, right? And then everything else is not. I'm not saying it's superfluous, but it's secondary, like the way you display that, right? And so my point in all this is that from design and even at the moment of implementation, you want to have in mind the way you output it, right? Like so the UI, but you don't want it to let it drive you. In fact, what I always say is you want to just focus on building what I call the shell version of the program itself, the fucking command line version of the program itself, because that's where you know, or that's where you can clearly see whether or not you build your class well, whether or not all your functions work as they should, whether or not maybe if you did some like input validation, that's when you can really check and test to make sure that it actually works as it should, right? And then from there on, you build it out. From there on, you find a nice kit or a nice library pertaining to, or that's essentially catered or predicated around the programming language you're going with, that essentially offers you um, a nice tool, a kit of like components, buttons, text area, text boxes, etc., etc. And then from there on, you can actually just go about like tying the algorithm that you build when you were building the shell program to these kits, right? And then from there on, you can just extend it. Maybe like hopefully the library allows you to um, implement your own custom appearance, right? So you can just have it designed and then like set it. All these things. But the point of it is, the main point is that what drives everything is the shell program, the fucking concrete classes, the objects being built well, right? It's not the embellishment all around it. And that was my main point. Because when it comes to security, you always want to think about what is most important to protect, right? And if you have a really strong idea of what that is, then you have a better way of going around not only just making sure that everything is programmed in a way that it's sound and solid, but then also thinking about like ways to like protect that. So adding padding, fuzzing data, all this shit, right? So that's kind of my point behind that. Always ensure that that works first, right? Always ensure that you know what the fuck you're actually building. Because if you don't even know that, then you're just going to be running into a wall constantly. You're constantly going to be discovering something that like completely shifts the fucking overall essence of the system solution that you're building, because it's not even set in stone. There's no set purpose. There's no set vision. There's no set goal. There's no set objective of what this system solution needs to achieve, right? Like, for example, Snapchat, it has to take a picture and be able to like be shareable to this particular infrastructure network set aside. For Facebook, you have to be able to like not just do things as a user, but also be able to like interact with it, right, from the back end side. If that's not even understood, then you kind of have no shot. And that was kind of my point of hammering on to the swag design phase, because that's where it gets hammered out. That's why I mentioned not just thinking about, oh, what we want to create, but trying to like put into words the scenario that you're facing, right? So here's a parking garage. It has 300 parking spots, and then there is so many. It has 3 tiers of parking passes, right? Every tier of parking pass only has a set number of parking passes allowed for that tier. And then on top of that, once the parking garage is full, we no longer issue out any parking passes. We actually turn customers away. And then from there on, you're like, okay. And then we're saying this is dealing with helping the business, that is the parking garage, operate. And so it like fine tunes, sharpens, hones, gives vector, gives direction, purpose, vision to your solution system, right? And that's kind of where I wanted to tie into another point, which is the idea of understanding that you kind of, I've kind of been mentioning this already, but I like to like just explicitly say it. The leaner that your implementation can be, the better. And what I mean by leaner is by focusing on only implementing the classes and objects that need to be there, right? Not just the nice to haves. Because it's so easy in the implementation phase is to like create a class for everything. But my point is, and what I really like, it really became crystal clear to me. The more classes you introduce, the more potential room for error that you introduce in your system or in your solution. And at the same time also, the more classes you introduce, the more vulnerable your solution system becomes, because now you introduce all these potential points of attacks where someone could take advantage of a vulnerability or a fault, not a fault, or a bad programming practice that you essentially did, right, in your code. Maybe you didn't um, protect all member variables, or maybe you were implementing stuff, and then like in that process you didn't set stuff as private, and so now they were vulnerable to like external use, right? Maybe you went ape shit with pointers, and then you don't really know what the fuck you're doing, so now there's all these pointers that are available for attacks, right? Like buffer overflow or hijacking attacks. There's all these possible issues that essentially the probability of them being used multiplies or it increases. And so that's why I talk about making your program as lean as possible. My personal rule of thumb is if I'm only doing one thing with a class, like say I want to build a class, like I want to make this particular thing, maybe I want to make parking spot its own class. But if at this moment I'm only doing one thing with it, then it doesn't make sense for me to create a class for it. I could just keep it into like the main parent object class and then just deal with it there. And the reason being is that, and that's something actually I saw firsthand myself, is that creating classes, as much as we don't think much about it, it's like fucking expensive. Like it actually is really expensive, because you have to think about first of all, there's a function call, and then there's like reference creator, constructor created, and then there's a destructor created, all this shit, right? And then depending on the programming language, some of them help you with this, but others do not. So you always have to like factor in how much resources available and how to most wisely use it, right? So the best way I would say it, if I'm only doing one thing, or if I'm thinking about creating an object or class and it's like there's only literally just one function in it, then it's best to not make it its class, right? But essentially, so I was debugging my program, and I just couldn't figure out what was up with it, right? Funny enough, it was just one of those I've been staring at the screen for hours too long, stupid mistakes, right? So I had switched I was writing a switch statement, and then I had switched my true and my false cases. So my true case was doing what my false cases was doing, and my false cases was doing what my true cases was doing. And so naturally, as I was just like print line everything, or count if you're using C++. So I was counting everything and then creating my own like custom message inside the switch statement, inside blah blah blah. And then I realized that essentially what happens, every single line of code gets executed in the code. And as much as I feel like we know it, we don't actually really sit down and think about what that fucking means. So prior to this, I always thought, for some reason, that if you have like if statements or whatnot, for one reason or the other, I always thought that the computer just knew. Say for example, your statement was checking the variable, checking a boolean to see if it's true or false, right? For one reason or the other, I always thought that the computer kind of remembered what the value for that boolean was at that particular time, and so it would just naturally just jump to what met that condition, right? So you have two if statements. One is, okay, if boolean equals true, blah, 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 right? And then there's another if statement, if boolean equals false, blah, blah, blah. For some reason or the other, I always thought that the computer just knew, and it would just jump to that fucking if statement that was most pertinent to it. But what I realized in debugging and counting my shit was that actually the compiler executes every single fucking line of code, right? So now think about if you're in like a huge program, and every time you're checking for a condition, you are making a call to a function, right? So you're like, if Boolean variable dot is this true, parentheses, right? You're making that call. Every single time you're making that call, you're adding to the call stack, right? And so now on top of that, if your function is in another object, then you're also making an external call. And whether people kind of figure this out or not, the more external actions occurring, the more expensive it is on the computer. And so that's kind of why I always talk about, or I was mentioning, keeping things lean. Because the more insular or the more internal, the more in within the class itself you can keep it, the faster it will be for performance. So that was kind of my bit on that, right? So keep it lean, and then on top of that, also, you want to make sure that at the level of implementation, you have identified all the possible factors that could affect the project itself, right? I'm talking about things like team member skill set. Like you want to really hammer that part down because it like makes a fucking world of a difference. It's the difference between someone essentially pulling the whole weight and like having like an even distribution of work, right? On top of that, it also helps with communication and trust because if everyone knows that they're not only on the same page, but they're at equal level of understanding as far as how to go about implementing things, then you won't feel any friction or resistance to asking a team member for help because you know that it's actually an option. When you feel like you can't trust the word coming from your teammate, that's when friction comes about because now all of a sudden you're like, oh shit, gotta do everything by myself. Can't really rely on anyone. I'm all alone, right? So skill set, and then on top of that, something I really wanted to mention is you want to identify the true limiting constraint in the implementation phase, right? So a lot of times people think it's like either time or money, right? But if you think about it, it could be a whole number of things. For example, if you have 6 weeks to build something, right, you have like a viable budget, but then at the same time, they want you to only use a particular technology, right? Well, let's say you know how to use that technology, but by nature of that technology, the way it's used, it actually has a huge, you can say, testing cost to it. Meaning, the way it, the way you use it, the way you write, maybe the syntax that's involved. Maybe it's like because of that, like the way that anything is done in that language, it requires a lot of testing because you're constantly double checking yourself, right? You have like all these dollar signs all over the place. You don't know if you actually wrote the right dollar sign, so you constantly have to test it, right? Or there's all these fucking dots all over the place. You don't know if you missed a dot somewhere or something, so you constantly have to test it. It might have a huge testing cost, and so because of that, that will actually you can get things done, but you won't be able to ensure that it's reliable. You're right. So my point is that you want to identify as many of those costs as possible, right? Maybe say for example you're building a hover car, right? And then you're building the system that the navigation system that goes into it, right? You start you've taken a snapshot at the design phase of the problem domain, so all the possible factors, right? And so you okay like so we have a magnetic reactor, a fusion reactor, some sort of like new energy shit that's like riding on the fucking waves of the earth. It's literally gliding, almost like a glider, and so that's our like power, or that's like our engine, right? It's sitting right at the bottom, and then you have these four what do you call those? kind of like think of like an airplane, the little flappy things, but they're like open and then they're kind of pointing at the ground to help with like navigating through the air, right? So car, and then you start thinking about the four sections because you want to make sure that you can always just check the status of each part or each wheel, if you want to call it that, right? And then you have contingency plans in case something happens for them. Then you think about the navigation system itself, right? Can it detect like turbulence, right? Then you start thinking about, okay, maybe I need to like think about density, right? How when I'm up high in the air, the temperature is maybe cooler, right? So I gotta like pick materials that are resistance, the resistance to any change in temperature, and they stay solid and flexible and usable across the entire spectrum that the temperature can take, whether it's hot, cold, or neither, right? And then you start thinking about also, well, what about other external factors, right? Like if I'm being scanned, right, by like a tower, radio tower, that actually creates turbulence, whether people know it or not, right? If like a plane is coming, it actually has its own like gravity and mass. It can pull me in, so I gotta make sure it's this sort of way, right? So you start identifying. You try to take as big of a, because essentially that's what the design phase. You're just taking a snapshot of the problem domain, and then now at the implementation phase, you start honing in on what actually matters, what's relevant, and what's negligible. That's the word I was looking for, right? Like sometimes some things by nature of like the way that it's being built, maybe you find a nice mineral that actually uses whatever energy it finds itself encountering, and so you don't have to worry about temperature. In fact, the fact that like whatever temperature it is, it's actually a plus because we can convert it to energy, right? There's all these things, but then you start hammering down, zoning in on what's more important and more important. But to go back is like, as you start thinking about all these things, you're like, oh shit. Even though I could like build something that would be useful to the flying, the navigation, the detection of objects, right? The start and stop, detection of like altitude, where are we at, right? You might have to actually go somewhere, talk to like pilots, get their first-hand experience, people that are up in the air all the time, right? And then maybe find out about like zoning, right? Zoning fucking protocols, how like they just want to make sure that no one runs into each other. And they're always essentially factoring in for the fastest possible object in the air, right? Because if something is traveling at like 3,000 miles an hour, like a fucking jet or a UFO, you want to make sure that you don't run into it, right? You want to make sure you can see it and have the time to actually move out of its way. And then you want to also like build safeguards in place or protocols in place to where you never run into each other's way by virtue of just like operating in one way or the other. These are all these things that like are costs in of themselves. Just going back and forth with the pilot, like going back and forth and like learning about zoning laws, going back and forth with manufacturers, going back and forth with like maybe energy people and like figuring out how new energy sources are being used and can be transformed. These are costs in of themselves, right? It's might be like a research, and this is literally at the implementation phase. And so my point is that every project has this sort of cost tied into it. I actually found in my head, when I was thinking about making this video, I had a way better way of kind of articulating it, but it's the best. This is what's coming out, right? It's like this like non-tangible cost that rears its head in the worst way if you don't actively seek it out, right? Sometimes it is just time, right? And ensuring that like you have something up and going before a particular time. Other times it's like you want to make sure that it works well, right? If you're building a fucking system for like a nuclear reactor, for example, you want to make sure that it can like shut down exactly when, right? And so maybe like reality or reliability is a factor. Other times it's like worrying about scale, right? Worrying if you're like dealing with like a cloud computing of sorts and you want to make sure that there's always resources available. Maybe it's like making sure that you have your um, new resource allocation math down right. There's all these little variables. But my point is the better and better you can identify what that is for you, the more of an idea and clarity you have a way of how to go about managing yourself, your time, your energy, your skill set, your awareness throughout the course of the project, right? You won't end up in this situation where you're fucking doing a death march. Like you're just sprinting, trying to get shit done, trying to just make sure that shit happens because you have a meeting tomorrow, blah, blah, blah. And that you just want to make sure you're not empty handed, right? Which leads to the next point is that I don't believe in like the necessity of meetings occurring all the time. I understand that maybe if in the past you've had groups that always weren't reliable as far as like delivering on time, you would want to implement something that an accountability system, right? That's all well and dandy, but I feel like there's better ways of going about it. Because you want to think about it from like when you're implementing, your mind is focused on achieving, making this one thing a reality. And every time you stop, you kind of lose momentum, right? You kind of like, you shift from that building creation mode to like, oh, gotta like now put in words what I just fucking did. And as much as it should be easy, sometimes it's just not because when you're in that creation mode, you're thinking really abstract. Like sometimes there's shit in your head, you're just connecting the dots. But when it comes to reality, you don't always know how to like artfully art link those things together, right? And so the way you come off might not actually be accurate to the way you actually intend on doing things, right? What I'm a fan of is the idea of what I call discovery meetings. Meeting is like, oh shit, bro, like I just realized in implementing this, we didn't iron out this wrinkle in the requirements phase. Oh shit, I just realized in implementing this, there is this fucking this thing this platform this particular programming language has a constraint, right? Maybe it's actually doing it, making us do more work, and then I found either another programming language that would be a lot simpler or a library that would cut out the work that we were planning on doing, right? Discovery meetings allow you to actually maintain momentum on whatever it is you're doing because you're only talking about things that are relevant to that train of thought of implementation that you currently have going on at the time. Furthermore, I feel like it's a lot more helpful because then people won't feel like they're just schlepping over to a meeting because they have to, because else their boss will fire them thinking that they're lazy. But rather now they'd be looking forward to it because when you're meeting, you know that something fucking swaggy is about to be said, right? So that's kind of um, that's like my personal thought on that. And obviously, someone will say, "What? Who the fuck are you? What the fuck do you know? Have you ever worked in like a big project?" And they're probably right. And I will 100% say that I'm probably wrong in that context. But I will still fight and say that actually I'm right because no one, until you've implemented it, until you've tried it, you won't know that it doesn't work, right? So there's always better ways of being accountable than just forcing someone to show up somewhere all the time, right? Maybe having them send their work with like a small little, this is what I did, this is what I can do, this is what I'm going to do, like typing them up instead of like forcing them to like stop what they're doing outright and just talk to you, right? So that's kind of how I think about it. Um, Now, there was something that I wanted to mention. Oh, so to go back to the concrete classes, now I want to talk about how once you focus on if you really know what the meats of your program is, the fucking what it's actually doing, what is that most important, most critical class or object doing, then you will have an advantage over people who don't know. Because once a lane opens up, you will be able to see how you can retrofit that object or class, adding it more functionalities, modifying it in a way to meet the needs of that lane, should it be the right thing. And I say that because sometimes you don't want to change, right? You don't want to change your system, right? You don't want to change your solution because on some level it's actually meeting a higher purpose. It's actually meeting a higher level vision, right? And the act of retrofitting it would actually take you away from that. Like you hear all the time of people like losing their way or like straying away from their mission statement, and I think it comes to that, right? We get greedy or we get tricked by like seeing money, and then we lose ourselves in it. Maybe we didn't realize that we weren't actually equipped or capable of meeting the demands of that lane, right? Because when you enter or merge into a new market, there's all these things we never think about that are really fucking real, right? Like just the cost of living and operating in that market, right? Maintenance, right? The cost of like innovation, right? Growth, cost of even just fucking holding on to talent, right? There's so many things, and so on top of that, you also got to think about um, the I mean, people know the laws of supply and demand, right? Like, if in that market it's really fucking saturated, right? There's not much growth or not much. Essentially, your prices are set by external factors, the market, right? Your peers, right? If there's like 3,000 people um, selling a system, and essentially their system is all essentially the same object of or class, you're not going to have much room to dictate what you want, right? And so now, because of that, it's a lot. It's a lot more likely that you will be dictated by them, right? Like the prices that you set for that system, right? Well, even no matter what model you choose, whether it's a licensing, subscription, like fair outright use, access to the platform, whatever it is, it's most likely going to be dictated by them because there's such a high supply of that particular system, that particular type, right? So my favorite thing in saying this is people talk a lot about laws of supply, but they don't talk a lot about the law of utility, right? And that's essentially the idea of that when you first when you first introduce a product or service, right? At its conception, it's its most useful. This is because whoever the founder, whatever, he saw a need, right? He saw like a real world problem, and so he sought out to solve it. So at its conception, it's most useful. But over time, what happens is it becomes least useful. This is simply by due to the nature of life and reality itself. Growth, innovation, kind of like inflation, it's the same thing in like tech or any business or any sort of business product or service. Things advance, evolve. Maybe there's advancements in technology. And so that particular system, solution, or whatever becomes less useful because there are easier and better ways of going about it. Oui, merci. So my point is the law of utility kind of reminds you that you always want to be providing value, right? Always. And so one way of doing it is by having like a sheer like laser cut idea or an understanding of what you actually have on hand, because then it allows you to preemptively see whether retrofitting whatever you have on hand is actually viable or not. Whether, and then more importantly, if it's actually the right thing, right? Because just as I just recently mentioned, sometimes it's actually not right. That's how a lot of people go out of business. They're like, oh, yeah, I'm gonna do this, and then they're at the wrong time, or and then they lost their like base, and so on and so on. So by having that in mind, you'll constantly seek out ways of being better, of like innovating, of providing more value, of being of use, of being useful to people. Because the more useful you are, what happens is it's a line, the most useful, least useful. And the more useful you are, it actually slows down that descent, if not actually almost like resetting it outright, right? And so this is where people talk about niches, right? So say you build like an antivirus, right? And then maybe you say you have two antiviruses, right? One is good for like one you can the reason why you can tell that it's clearly good for maybe common use malware is because it only focuses on scanning like that most higher level part of the OS, right? Like files, etc., etc. Files. Maybe it also has like a built-in port scanner, so it like hardens your like your what do you call your ports, your OS ports, stuff like that, right? And then maybe you have one that's like a step above that, meaning it doesn't only do that, but then it also checks for like integrity of drivers, like OS drivers. It knows what OS you have, so it knows what files need to be there. You call like let's call it critical files, right? Like, and then like maybe it like actively seeks to make sure that's there all the time, right? Maybe it even has like something that's like built into like looking at your fucking memory itself, right? So dealing with like um, hard disk integrity, partitioning, that sort of shit, right? And then you can clearly tell that just by the way that one, or just based on what one antivirus has, it's most likely going to be useful to one part of a market, right? Say this is like the entire market of antivirus users, and then here's the market for like maybe like personal home users, like the ones that just surf the web and play video games, right? They don't do much anything. And then this one is like maybe like advanced level users. Maybe these are like admins. Maybe this is even like an enterprise. This is like government enterprises, that sort of shit. And then like that's more focused on that. My point is, this is why understanding your concrete class, your concrete object, what the fuck you actually have on hand is important, because you will best know where your sweet spot is, right? If your thing isn't that technical, then there's no point in trying to go after those customers, because on some level you would actually be annoying them, right? Like you will not be useful to them, because their problems are on a higher level than what you're kind of solving, right? So always have that in mind. And it's kind of funny in saying this, because this idea came about a while ago. I think it was like sometime in May, and like I had a dream, and it was one of those dreams where it's not really a dream. Like there is some shit going on here, and you can't put your finger on it. Jesus, no, I'm just kidding. But like, so I was sitting somewhere, and like I found myself like talking to like an old like high school friend of mine. So like I was talking to him, and then like his parents, like his dad, right? And so we're just kind of like vibing, and then it kind of got on into like a topic on like business, right? And it was essentially we started just talking about like specialization of services, or I got into this rant on like specialize on like the law of utility. Even mentioned the law of averages, but I couldn't understand. When I woke up, I couldn't put my head to what I meant. I think it was essentially tied to like just setting your prices and understanding um, all the factors behind it, which is another reason why I fucking so glad I took micro and macroeconomics. Slavinsky, you the MVP, you the real MVP. But I got onto this rant and I started talking about how the specialization of services and products due to essentially the pressure and forces acting behind the law of utility will essentially lead us to this place where it's just you will essentially have this tech. It'll be like this. It's kind of like technology will head in a way to where there will be an emergence of what I called lightweight products, right? So kind of think of like a phone only accepting lightweight apps and phones accepting non-lightweight apps. Like it's gonna like just they're gonna split, right? One kind of phone will only accept this kind of like overall what do you I don't want to use the word structure. I want to say the way that you build your concrete class and then all the concrete classes, right, that turns into a system, right, and the functions that are involved. And then like the way that you go about managing your memory, kind of going back to like making sure your stuff stays lean, having the computer in mind. Oh yeah, caveat. I want to be that person that's like, but how does this make the computer feel? Like when you think about how it has to execute every single line of code and then all the work that it's involved, I kind of want to be like that person that reminds people of that, right? And all the things that that entails. But essentially, the way how good you are at doing that will essentially cause your app or your product, your service or your system to become this sort of app, like a lightweight app if you keep it nice and lean, and a non-lightweight app if you don't, right? And so it got me to think about how, if you think about it, that's almost like the evolution of like some of like the main commercial technologies, right? For example, you have a game, right? In the beginning, games were just like text, like it was just pure text. I think what is it? Mud is what people would call it. So you just had text line, and then like the text would show you something, right? And then it kind of evolved, right? Maybe instead of just one player being able to play, then you get more than one player, right? And that's like the kind of the evolution of like what they call MUDs, right? Where it's a text game, but then now you're also interacting with other people. And at some point, that emerged from that to like graphics game. And if you want to think about it, that's kind of the reason why RuneScape Classic was such a game changer. Because for the first time, not only do you have graphics, but you could play with other people in a semi or pretty interactive like game environment, right? Like you could chop trees, you could fish, right? You could you could go to the wilderness and like kill other players. There's all this cool things that for the first like had never really um, been so easy to access across any system, right? Because all the other games, for example, you had to like download something or you had to have like a particular computer. But this was like developed in Java, right? So as long as you had internet, you could access it. And they just made it really easy to play and to access. So then like that's kind of that went from there to like graphic user interface based games, and so on and so on, right? And then like another one I was thinking about is like something as like the beginning. Can you think about the beginning of like the first database? There was a simple notepad, and someone was literally writing shit, and then maybe it evolved to like a spreadsheet, right? So Microsoft Excel, kind of one of the reasons why I think was it the Mac or the Windows, one of those computers exploded was because of business uses, right? Like people saw the importance of having like a word processor and a spreadsheet, and so they bought it. They bought computers just for that reason, right? So now from the spreadsheet, you get like maybe um, what do you call it? Relational database management system like Oracle, right? Where now on top of the spreadsheet, now you essentially are introduced capabilities that essentially allow you to manage who has access to all, not only managing that database but seeing it, right? So you could literally set who you could set permissions as far as okay, you can actually add mess with a table, but you can't. And then like you can only see the table, but you can't mess with it, right? And then like it introduced this idea of like roles, right? And high account user account hierarchy, if you want to think about it like that. You have an administrator, a second level administrator, third level, right? And then from that to like essentially what you well so I mentioned simple database like the relational database, right? So from a spreadsheet maybe sort of thing to like this huge like management in user account management infused or user account management capability infused program, right? And it just made me think, and this is literally happening in the dream, right? And I was thinking about how, like, essentially, if you think about it, it all goes back to that law of utility. Because on one hand, what happens is, say you have something, and then as time goes by, instead of just sitting on it, you find a way to. I use the word repurpose, right? So essentially, I talked about how business development at the end of the day was um, the idea of essentially repurposing your assets due to the emergence of new capital in the business sector. Essentially, this new capital creates and leaves opportunity for all people, right? Um, so I kind of talked about how, for example, a family might have like a factory of sorts, right? And so now and like that's one generation, and then the next generation they decide to turn this factory to like a sort of retail, right? So they move their machines out of the factory, but then they keep the space, and so now like they have a place they can sell stuff off, right? And then on top of that, maybe they even keep the equipment. So now they can not only service like production driven companies, but then they also have their own line of product on hand, right? And then I talked about how now you move forward, and because of the internet, you're able to actually reduce the cost or the barrier to entry of markets, right? So I said you press a few buttons and you're in a business offering a service or product, and it's kind of funny, but I don't know why, but then like the dream kind of like it switched to like this scene, and I was just talking to this guy, and essentially he was like this huge like manufacturing mogul on some hand, like he had this huge manufacturing plant, and essentially we were talking about how like sometimes I don't know how else to put it, but sometimes you're thinking things and then it like ushers things forward, right? So I was talking about how like it. This is how it segued to it. So I was like, my thought was like being grateful and wanting to give back led to choosing a passion project, right? And so in that passion project, you develop yourself, right? Your willpower increases every time you overcome resistance, right? So maybe you're trying to learn something and you're having a hard time, but you just push through and push through, and then you break that threshold, right? And you gain experience, just like a Pokemon, and then your skill increases, and it turns into something else. Fire blast becomes flamethrower. But then I was like talking about how like resistance is like a force, an ever pervading sensation of being pulled back, right? And so um having a passion project. So I guess I was kind of like, this is where I'm talking to the guy, right? And I'm like interviewing him. I think not interviewing, we're just talking. And I asked him like essentially how did he end up here? And he was saying something like having a passion project um, is what turned him into a learning machine, right? And so by learning, he just had started having all these insights, right? One of them was the fact that like people really didn't see the internet for what it could be, right? So instead of just focusing on how it could help their business be repurposed in another way and um, provide more value, all it a lot of people were just frozen in fear because they realized the impact that the internet would have, right? So the ones that realized it were extremely happy because they could build on top of it. And so, like, an enormous sense of gratitude is witnessed and expressed when witnessing the extreme level of complexity in the architecture of the systems that operate some of the platforms and technologies built on top of the internet, right? Things like Facebook, where now you're literally your own content creator, your own publisher, your own distributor, right? Your own entity, right? But you're literally living on top of this platform, and this platform is built on top of the internet. Back then, like the cost of an infrastructure like that was high, right? Not only would you have to like buy the megaphone, but then you'd have to like be at the places where people would most likely want to hear you. You'd have to make sure that you were someone who was worth listening to. You had to make sure that like people wouldn't give you shit just by the sake of the fact that they were like the gatekeeper of sorts at the time, right? There were all these things. And so, but now today you can just get started if you want to today, right now. And so I was like, it's like, yay, you can have your own land. And then, oh my fucking God, there's this robot magic lamp thingy mabob that literally grants you every single one of your desires, right? So he goes on. I go on, and this guy is talking about how like this guy owned a manufacturing company and wanting to have all the capabilities necessary to position his products in the right way. And thanks to the internet, he was able to create a media company of sorts that does just that, right? And so my point in saying all this is that because of the law of utility and having that in mind, not only will your assets always be providing value, but on some level they'll always be evolving in and of themselves, right? And I feel like if you think about how to essentially have a business that preserves itself from generations to generations, it's kind of that always letting the idea of providing value, of being of use, of serving be the driving factor behind everything that you do. That was a fucking mouthful. Yeah, so that was kind of what I wanted to say on that. I had another point, but it literally just slipped my mind. Um, I guess I'll leave it at that. I think it had to do with implementation, um, but can't remember. I'm sorry, guys. My memory shit. I'm fucking newbie and damn and a loser. Anyways, that was still a fucking mouthful. Hope you guys got something out of this. And as always, swag the fuck out. Oh, I remembered. It was on implementation. And one bit that I wanted to mention, I forgot to talk about later, was the fact that as you're implementing, one other thing that you want to make really, really fucking essentially spot is this call for what I guess we can call real live objects. What do I mean by that? Real live objects, I guess I'll define here, would essentially be components in your system solution that literally evolve, grow, and maybe expand with the unfolding of time itself, right? Something like a time clock, right? Something like maybe let's take an example of like you have a component on a website, and this is like the most simplest way I think about it. And for those of you who know, it's I'm making the distinction between static and dynamic. That's essentially what I'm talking about, right? So for a website, it's like you have the component, and then it displays information, but it's done real time, meaning you don't have to constantly press a refresh button. If like something is being updated, maybe like you display total parking passes sold, right? You don't want to constantly refresh it. A counter, right? Visitor counter. You don't want to constantly refresh it. You want to actually display on the page itself without having to refresh. That would be a real time object or real live object, right? Or it would be a dynamic object. And my point is, you want to highlight if you have any of those in your solution system, because those are the things, if you think about it, that not only introduce a lot of headaches, but those are the things that will most likely will have to always constantly be maintained and updated. Why? Because as whatever technology you're using to implement grows or evolves, some things get deprecated while some things get created, right? So you might be implementing or including a particular library to essentially implement that dynamic object, but then maybe in the newer version of the programming language, that particular library gets deprecated, maybe for security reasons, maybe for something else. And so now you have to actually scramble to find the way that is done now, right? Like you have to find the new way to do it. And that's kind of why I'm always striving to create original and authentic code without relying too much on libraries, because logic is timeless, right? If you have like a function that's like variable equals 5 plus 1, that will always be true. That will always work for eternity. But if you have a thing that's like variable equals something dot get something, and that's using a library from outside, you can't guarantee 100% that library is always going to work. And so that's why I'm always cautioning people against Stack Overflowing. Take that back. Take that back. Cautioning people against just using libraries or frameworks just for the hell, just because it's easy. Because on some level, not only is that just lazy, but it's also where you start to lose sight of what it is you're actually doing. Like you start to not be able to say, this is what the fuck this is doing. I know it because I built it myself, right? So you always want to be able to say that I built it myself, like as much as fucking possible. Because not only does it make debugging easier, not only does it make communicating easier, but it also makes reliability for longevity much, much of a higher probability of occurring, right? It's much more likely that that's gonna last than some shit you just fucking copy pasted and imported. Um, that was kind of my bit, but yeah, identify the static and dynamic objects, if any, because that really fucking changes the essence of whatever it is you're building. And that's actually another one of those, I guess you would call non-tangible costs that I wanted to mention. I think it might have been one of the ones that I was looking for when I was scrabbling earlier. Really gotta mention that because that one was really fucking important. Anyways, I'm leaving for now. Leaving for real this time. Swag the fuck out. Hey guys, Steven here. And in editing this, I felt like I had to drive another point home. So this is on essentially keeping your program lean and not making a class out of everything. And I kind of wanted to help illustrate the idea behind that and how essentially when you add in a whole bunch of objects, especially if you're using some sort of inheritance or a relationship to your data structures, it's going to add unnecessary padding. So what do I mean by that? Let's say that you have a system that runs on these particular classes. So there's a class called customer, right? This is a customer class, and it holds. Let's go back to that parking garage example I mentioned. It holds an object that's it holds a vehicle object, and then it holds a parking pass object, right? The vehicle object essentially takes care of all the vehicle information, right, for that customer. The year, make, model, etc., right? And then the parking pass object holds all the information for that customer's particular parking pass. So parking pass type, right? How long, how long of a duration is that pass going to be valid? Maybe depending on the parking pass system or the parking pass business, that pass might only be valid for a day or a month or blah blah blah, right? And then you might have a Boolean variable that's is it still valid, right? So these are the information that this holds. This is the information that vehicle object holds. And this customer object, on top of having these two objects, it also holds stuff for the customer. So name, number, etc. You get the gist, right? Now, my point in being careful is that, let's say for this example, right? One way of looking at it is like this, right? Another way of looking at it, let's say that the customer is one level of abstraction, meaning this is one level of exposing data, right? And because it's the parent, it's the highest level. Meaning when you create a customer, you're going to create these two objects automatically. But because this customer object holds these two objects, right? So then there's another level of abstraction, and that's the level that houses the two different objects, right? So this is the vehicle, this is the parking pass, this is the customer. Now, my point in talking about padding is that if, for example, um, let's remove this real quick. If, for example, we were to add another object, right? Say that there is a parking garage object that creates this customer object, right? And this customer object, as we've been talking about, creates these objects. So now the parking garage object becomes the highest level of abstraction. Now that point in padding is that essentially for this parking garage object to modify any of the customer's vehicle data, it's going to have this system is going to need to have or implement functions within the customer object that make it accessible to the parking garage object. In other words, you're going to have in the vehicle object class or in the vehicle class, you're going to have its getters and setters, right? Naturally, right? And then the getters and setters are going to be used by the customers, right? But because these objects are they're on some level they're not on the same access level. Vehicle is not on the same access level to parking garage as customer is. You're going to have to create what I call padding, or some people on some level you can think of it as like an API for functions or an API for object oriented. But you're gonna have to create another function within this class that deals with calling this vehicle's getters and setters, right? So within here, not only will you have the getters and setters that are particular to the customer class, but then you're also going to have to create getters and setters for this so that this can access it. Because again, this holds the customer object, and then the customer holds the vehicle and parking pass, right? And so for you to use any of the parking pass functions, you essentially have to create a function within the customer class so that the parking pass can reference it. Now, my point in this is that this is actually a lot of padding, meaning essentially your customer class is going to get huge because all of a sudden there's just this whole get get vehicle model, right? And all it does is just return. It's gonna return vehicle dot get model, right? And it's gonna necessarily make that customer class a lot fucking bigger. And then to add to that, we're not even talking about the human factors, right? So someone can like, as they're creating it, instead of using, excuse me, instead of using get vehicle model, they start being creative with it. Maybe they're on the customer side, and they're like trying to contextualize the reason why they would call upon that particular function, and so it changes name, and this fucking adds error. Now all of a sudden, instead of like things being streamlined, you start fucking having things being called different things at different levels, right? One class it's like called it's literally just a get model, set model, and another class is gonna be like get car, set car, right? Now there is obviously some like sound programming practices to avoid this, like one of them being like name the same thing across all levels. So if you're just trying to return the make, and if you're just trying to get the model or you're just trying to set the model, make sure that whatever at whatever higher level abstraction you're dealing with. So if you're in the customer class and you're creating that function that's exposing those um, vehicle class functions to the parking garage, you want to make sure that it's just literally called get vehicle or get model as well, right? So there are things you can go about doing to essentially organize yourself in a way that like you reduce the margin of error. But my point is that margin of error is still there. And this is just a simple fucking this is a simple scenario. Can you imagine now, like in a big fucking system, like maybe you're dealing with like a system for an airplane or a system for like a nuclear reactor, that sort of shit. Just how much more complicated and convoluted things can be, right? This is why I went back to like, or why I was stressing the importance of only implementing that which needs to be there, and then um, not creating a class for every single thing, but just incorporating it into one class, because that fucking adds padding. Just the act of like from this customer having this customer class dealing with its data member variables and the getter and setters that are respective to those data member variables, to now dealing with all these data exposure, you can call them, functions, will just make things radically bigger for no reason. And in my head, I call that padding, because it's a necessary, it's only necessary, it's a necessary evil, because you have to find a way for this parking garage to deal with this stuff, right? For this parking garage to be this parking garage object to be able to modify the vehicle data member variables or the parking pass data member variables, but it's not doing anything else. And in my head, a function is always doing something new, right? That's the whole point of creating it. So if you're creating a whole bunch of things that are just doing data exposure, it's just padding in my head. And that's essentially what I meant by that. So when you're implementing it, try to keep your program as lean as possible, having this idea of these levels to this shit in mind, right? Because the more levels you have, the more padded that class that's in between the higher level and lower level is going to be. And then that introduces vulnerabilities as far as security goes. Um, Hope this made sense. And for sure this time I'm heading out. Hope you guys got something out of this. And as always, swag the fuck out.